Welcome friends, my name is Jason Chen. In this video, I will demonstrate a batch processing based big data pipeline for web access anomaly detection and analysis. So the front end of the web access monitoring system are installed as mobile app and browser add-on on targeted devices such as desktop, smartphone, laptop, and tablet. Upon every web access request from the device, user's IP, URL, timestamp are called and sent to the backend for anomaly detection and analysis. So this is an overview of the data pipeline. I will illustrate the data pipeline in this part. Then I will demo the visualization platform. So the web access log data are stored in HDFS. Then I use PixScript to perform ETL, extraction, transformation, and load. Data are loaded into Spark engine, and I use k-means in the MLlib to do the anomaly detection. And some anomalies are filtered out by random forest classification model. Then the results are presented to analyst. Then the analyst may want to take a look at all the activities from a certain IP to decide the next step. Because of this, so all the data are converted to JSON format and stored into search engine ElasticSearch. So analysts can check all the activities from a certain IP in Kibana. So let me show you what's the input look like and what's the output look like to get a better understanding of what's going on. So initially, all the data are stored in HDFS. So for example, in this record, so this is the user's IP, this is the timestamp, and this is the URL, this is the category of this URL, and sometimes the endpoint browser are also available. Then next, this data goes through the ETL process. Then we got the output looks like this. So we extract the IP information and we use GeoIP to map the IP to country code. And this is the hour extract from the timestamp. This is the category of the URL, country code again. This is the country number for machine learning purpose. Category again, category number for machine learning purpose. Then I introduce some anomalies into the datasets. Then we have the data look like this. So basically, this record are introduced by myself as anomaly. So this user try to access a porn and adult website from India at 2 a.m. So typically, this kind of web access is categorized as anomaly. Then, after anomaly detection process, then the output before filter look like this. Okay. So this 18 means the cluster number in K-means algorithm. This is the IP and from spam, and this is the hour. This is category, and this is the country number, and category again, category number. So this means someone from spam trying to access an adult and porn website at midnight. So this one is an anomaly. But the problem is many normal access are also classified as anomaly. For example, this one, someone from Canada try to access a business and the economy website at 8 a.m. So it looks perfectly fine. That's why we need to use another supervised classification model to filter out some anomalies so that the false positive can be reduced. So after filter, the result look like this. Okay. So the 0 means it's anomaly. 1 means it's normal. For example, this one, action. So we can find that some anomalies are classified as normal. In the future, we can fine-tune the algorithm both in the anomaly detection k-means model and in the random forest classification model to improve the accuracy. We can also try to normalize and standardize data for the machine learning model. Okay. But as you can see, most normal ones are labeled as 1, which means this one can be filtered out from the previous result. Okay. So at this step, data are converted to JSON format and stored into ElasticSearch. Okay, we convert the raw web access log data to the JSON format. Okay. Then for example, the analyst want to check all the activities from this IP to decide what's the next step for this user. So we can check it from Kibana. For example, okay, we find 305 records from this IP address. So as we can see that most of the URL this user tried to access is adult and porn, right? Even though the category is unknown, we can still tell this one belongs to adult and porn. For example, this one. So the analyst can block this user or send a warning to this user accordingly. Okay, let's go back. Let me demo the visualization platform. Okay, so I use Druid data warehouse and use Superset to connect to Druid. So in Superset dashboard, I already created several slides to help us get more insights about the data. For example, I create a map. So the more web accesses from this area, the darker this area is. So United States, Canada, okay. We can also view the pie chart of different URL category. And also the timeline. So there are many visualization types we can leverage for cybersecurity scene system. So for example, so Superset provides map box, horizon, heat map, as you can see, so many different kind of visualization we can use. Time series, pie chart, bar chart. Okay. Okay. Thanks for watching. I hope you enjoy this project.